everyone, we're going to find the area of the region enclosed by one loop of the curve r equals 4 cosine of 3 theta. This is a flower with 3 petals. I did a little sketch here, and I'm going to use this one. So I traced it out a little bit, just a sketch. And so we know that the curve passes through the pole when r equals 0. So let's set r equals 0, and we have 4 cosine of 3 theta equals 0. Divide both sides by 4, you get cosine of 3 theta equals 0. So this will be true when 3 theta equals pi divided by 2 plus every pi times n, for n is some integer. All right. Therefore, dividing by 3, we're going to get theta equals pi divided by 6 plus pi divided by 3n. So the part of the shaded loop above the curve is traced out right here for theta equals 0. Let me use green. I'll just put it here. Theta equals 0 to pi divided by 6. And then below the curve here, it's traced out to negative pi divided by 6. So we're going to use our limits of integration as negative pi divided by 6 to pi divided by 6. All right, so let's do that. We're going to take our area equals, our limits of integration are going to be negative pi divided by 6 to pi divided by 6. And then our formula is given 1/2 r squared d theta. Our r happens to be 4 cosine of 3 theta. All right, I'm going to bring out the 1/2. And this is going to give me, let's go ahead before we start. Since these are the same, let's use our properties of integration and write this as 2 times the integral from 0 to pi divided by 6. All right, now I still have my 1/2, and I'm going to square this. This is going to give me 16 cosine squared of 3 theta d theta. All right. Now what I can do is this is going to be 8, and 8 times 2 is 16. So we're going to get 16 times the integral from 0 to pi divided by 6 of, and I'm going to simplify this using properties of my identities. So I'm going to write this as 1/2 1 plus cosine. Usually it's 2 theta, but since we have a 3, it's going to be 6 theta, d theta. All right, and next step we're going to do is multiply these two. So that's going to give me 8. So we're going to have 8 times the integral of 0 to pi divided by 6 of 1 plus cosine of 6 theta d theta. All right, this is going to give me 8. Let's integrate theta plus 1/6 antiderivative of cosine is going to be sine of 6 theta. And we're evaluating this from 0 to pi divided by 6. All right, so what happens is you're going to get 8 times pi divided by 6 plus, if you plug in pi divided by 6 here, you get sine of pi is 0. So that's 0, and then you're going to have minus 0, or plus here. So basically what we have is this is our final answer. So this is going to be 4 pi divided by 3 when you simplify it. And that's the area of one loop of the curve. Thank you. Have a nice day. Bye-bye.